Hello students, welcome back to Chemical Kinetics. In this module, we will understand the first type of rate of reaction, which is the average rate of reaction. We will also see how to determine the average rate of reaction with the help of graph. But first, I want you to consider a highway. And on this highway, we have a vehicle. Say this vehicle wants to travel from point A to point D. While making this journey, the speed of the vehicle may vary due to various reasons. So as you can see, while making this journey from B to C, the vehicle goes very slow. And whoa, what was that? From C to D, it just zoomed past. But if I ask you to calculate the average speed of this vehicle, will you take into account the fact that it had slowed down between B and C? Of course no. So I can say that the average speed of this vehicle is nothing but the overall distance upon overall time taken. And overall distance is nothing but overall change in position divided by overall time taken. This will be the average speed of the vehicle. If I take the same idea and apply it to a chemical reaction, we know that instead of position, the concentration will change. So if, say, I have to find the average speed or average rate of a chemical reaction, I can say that this rate is nothing but C2 minus C1, that is overall change in concentration upon overall time taken. This can also be represented as delta C upon delta T, where delta C is the overall change in concentration and delta T is the overall time taken. This itself is the definition of average rate. So let's take a look at it. Average rate of a chemical reaction is change in concentration of reactant or product measured over a definite interval of time. During this interval of time, the instantaneous rate may be different, but we are talking about average. So we take the overall facts into account, overall change in concentration upon overall time taken. Let us understand this with the help of a graph. Say I were to plot a graph of concentration of the reactants versus time. When the time hasn't even started, when time is zero, the reaction has not started yet. So the concentration of the reactants will be maximum. That's our point right there on the y-axis. As the time progresses to T1, the reactant concentration will now reduce to R1. Naturally, as the time progresses, the reactants will react and they'll go away. So now this will be my point right here. As the time progresses even further to T2, the reactant concentration would have now decreased to R2. This will be our point right here on the graph. If I draw a profile of this graph, this is what it will look like. I know that average rate is C2 minus C1 upon T2 minus T1. So let us calculate the average rate between time T1 and T2. This is what it will look like. The R average, which is the average rate, is nothing but minus delta R by delta T. Delta R is nothing but change in concentration of reactants and delta T is the change in time. So here, this negative sign indicates that the reactant concentration is decreasing with time. Also, if you remember, this negative sign keeps the overall rate of the reaction positive. If I expand this and write, it will be minus of R2 minus R1 upon T2 minus T1. If you think about it carefully, say I were to draw a line between T1 R1 and T2 R2. What I'm doing here is I'm just calculating slope of that line, because slope of any line is y2 minus y1 upon x2 minus x1. That's exactly what I'm doing here. R2 minus R1 upon T2 minus T1. And the negative sign indicates that it's a downward slope. If I do the same thing for products, so I plot concentration of products versus time. Now, at time T1, say the concentration is P1. That's our point right there on the graph. If the time progresses from T1 to T2, now my product concentration will increase from P1 to P2. So we have this point right here. And if I were to draw an entire profile of the graph, this is what it will look like. Once again, if we want to find the average rate between T1 and T2, all we have to do is, our average is nothing but delta P upon delta T. A positive sign indicating that the products are increasing with time. Once again, if you check, this is the difference in time, delta T, and this is the difference in concentration. Now you will see that the difference in concentration is positive in this case. If we have to expand this, it will be P2 minus P1 upon T2 minus T1. Once again, we are calculating slope of the line. Which line? Between T1 P1 and T2 P2. So that's how we calculate the average rate of any reaction with the help of equation and with the help of a graph. In the next module, we will understand how instantaneous rate of reaction works. Till then, thank you.